Lesson 4. Application to Mechanics. 3D vectors can be used to model problems in mechanics in the same way that they're used in 2D. Let's do one example. A particle with mass 0.5 kilograms is acted on by three forces. F1 is equal to 2I minus j plus 2k newtons. F2 is equal to minus I plus 3j minus 3k newtons. And F3 is equal to 4I minus 3j minus 2k newtons. Part A. Find the resultant force R on the particle. Part B. Find the acceleration of the particle in IJK notation. Part C. Find the magnitude of the acceleration. And then, given that the particle starts from rest, Part D. Find the distance travelled by the particle in the first 6 seconds. For Part A, the resultant force will just be the sum of the forces acting on the particle. And so that will be F1 plus F2 plus F3. If we write them in column vector form, it will be equal to 2 minus 1, 2, plus minus 1, 3, minus 3, plus 4, 3, minus 2. 4 minus 3 minus 2. And this will give you 5 minus 1 minus 3. And so therefore, R is equal to 5I minus j minus 3k newtons. For part B, we know that F is equal to ma. In this case, F and A are vectors. And so we know that F will be the resultant force, 5I minus j minus 3k, is equal to 0.5, which is the mass, multiplied by the vector A. And so therefore, A will be equal to 5I minus j minus 3k divided by 0.5, or multiplied by 2, which will give you 10I minus 2j minus 6k meters squared per second. For part C, the magnitude of the acceleration, which we write the same way as writing the modulus of A, will be equal to the length of A, which is the square root of 10 squared plus negative 2 squared plus negative 6 squared, which will give you the square root of 140 meters squared per second, which you can also write as 2 root 35 if you wish. For part D, as the particle starts from rest, the acceleration will be in the same direction as its motion, so we can assume it's moving in a straight line with constant acceleration. This means that we can use the Suvat formula to find the distance travelled. We know as it starts from rest that its initial velocity will be equal to 0. We know that the magnitude of the acceleration will be equal to 2 root 35, or the square root of 140 meters squared per second, meters per second squared, and that the time will be 6 seconds, and so we need to find S. Now, the Suvat formula we can use here is S equals ut plus half at squared. As u is 0, we can just write this as half at squared, which will be a half times root 140, or 2 root 35, multiplied by 6 squared, which will give you 36 times the square root of 35 meters. And that's about it.